So what we have today is a slightly different presentation than have done previous years on many different topics. Thank you, thank you. This time we're going to take one execution topic around sustainability. As a team here, we're going to go through the overview and then actually take a business case and look at it in live software. So we are going to be doing live demos here. Okay, okay. So yeah, I'm going to take a look at the sustainability. Trini mentioned it a little bit earlier today. I'll do a little product roadmap overview of where we're at with the software, kind of some key concepts that we have, and really looking at the current capability that is here today in our 24C and 25A release, with the intention that folks here start taking a look at ways that they can uptake and implement this in your OTM instance. And then that'll lead us into a demo. Next. Okay, so reiterate, our key parts, or what we're driving at, is the ability with sustainability, with logistics part of it here, is to be able to understand how much of a emissions, what are we taking a look at here. So being able to capture the details that drive our emissions calculations, the ability to calculate our CO2 as well as other gases that are involved with emissions, the ability to analyze and take a look at by modes, by regions, where we're working on here, ability to design a more sustainable transportation network, and then the goal is to be able to innovate and be able to plan for new capabilities such as our EV vehicles. One of the things that's slightly different that we have with our approach that we've done here versus some other vendors or what some of the customers have done is this is not a separate capability where off on the side we're going to take the shipments out of OTM and go calculate and do reporting on emissions. I want you to have a takeaway here to realize that the capabilities that we've developed are more about having all parts of the components being able to understand and calculate emissions. So from the decision support piece there, what that would mean is as a planner, when you're interacting with OTM, maybe doing a change service provider or show network routing options, all of those capabilities inside of OTM will now display to you, here's the total transportation cost, as well as here is the planned total emissions calculations. So this idea of taking these data points will be baking it completely into the solution. So you'll be seeing that in your decision support. We'll be seeing that in rating, our rating engines being able to understand and do these calculations. We'll be seeing it in our shipment data structure, persisting it. So this concept of doing sustainability and understanding emissions, you'll see it throughout the entire footprint of OTM GTM. Next. As well as we understand that these calculations, computing your transportation emissions values, will fold up into a larger platform that you're working on for your sustainability. So the model I have here is doing the Fusion one from Oracle, but this could as well be another platform that you're implementing. The idea being that those sources that we've calculated the emissions, we have a rich set of APIs, and we've designed the solution to be able to plug into a larger ecosystem. So here, maybe a sustainability ledger is getting managed by a different application, and we are feeding that data up in there. Okay. So just to see Where we are in our delivery area is we've delivered the key pieces here around capturing emissions, calculation engines, and analyzing and the design component. This is all available here, 25A, and then we'll be moving a little bit over to the futures. Okay, so a couple key concepts when you start working with it, with OTM. There's a whole new set of data structures around your kind of ESG, your emissions activities. What that's helping us model is the understanding that a shipment in OTM could be a door-to-door move that we've modeled, that the freight forwarder is doing, and that the activity records that we're going to have to understand against that shipment may be multiple ones. We may have to understand the dray move, the ocean, etc. Each one of those activities get sent over for emissions calculations to our engine. Another one could be a road transport here in Europe where a portion of that move is done by ferry. We need to be able to understand against a single shipment that there's multiple activities happening. Each one of them we have to feed into our calculation engine. So we've kind of built that flexibility right in. We excuse me, also have the ability to understand to say there's going to be capabilities where shipments outside of your OTM planning, you're going to want to feed in and we'll be calculating emissions for those. So that's what we have on the platform here, a key concept around ESG activity. Next slide. And then again, reiterating the fact that the RBIs here, we have an ability to, in our rating engine, to be able to calculate and influence the cost of a shipment based on your total emissions here. And the data fields that we have here are going to be, stored on our shipment records. That's available from integrations. That's going to get folded into our allocation engines, as well as displayed on many of the screens. And we'll see those later. The workbench. So this ability to bring these concepts into our workbench. We'll be taking a look at those. And analytics. So we'll see some dashboards that are built with showing emissions values, and we have delivered, and you'll see our total planned emissions values, CO2e, in our analytics model. And then the last one is we'll be folding this into L&M as well. So this is the ability with your logistics network modeling capabilities, is you could run scenarios that will say, what if I did a slight commitment allocation ratio with my carrier base? What is that impacting for my cost? But also, what is my planned CO2 emissions going to be based on that different carriers? Carriers have different scoring capabilities that we have there in the emissions calculation, as well as areas where you're trying to make a mode switch. Well, if I actually take and shift some of this air freight here, how is that going to impact my network? How is that going to impact my cost? How is that going to impact my planned CO2 emissions values? So L&M will become a very key, I think, component here in our entire offering out to the field. And I think I'm about, one last slide here before we get to start seeing this all live working. Just a couple key things from the foundation. Again, reiterating that these values that you'll see are on the shipment data models, on all of the screens, and analytics, rating engine, etc. Another area that we have here is flexibility. What would it be an OTM feature if we weren't going to make it infinitely flexible? So we have the ability to have you as customers, because as we've been talking to many folks, you're doing these emissions calculations at different points in the process. So what we're able to design here is you can configure to say, I want to calculate all of these activities and my emissions calculation right in the heart of my bulk plan, because I'm wanting to influence my plan based on these calculated values. So in which case, then that's how you would drive it. Other customers are saying, no, not really quite there yet. What I want to do is have the bulk plan produce the optimal shipment, and then at the end of the bulk plan run, have it calculate the planned emissions value so that I can see that through my entire decision support process, and we can do that there. Other folks might say, hey, no, I really want to walk first. What I want to do is I want to calculate them after execution for reporting purposes. So it's very flexible in terms of where you configure and how OTM will be calculating your emissions. We have your decision support actions. You'll begin to see all the values here. And then we have our REST APIs. Again, because this is a lot of new capabilities here, they're being offered out as REST APIs for our activity records. And with that, we're going to start to see the demo.
Thank you. Okay, so what we are seeing that is in today's world, understanding and managing the transportation emissions is no longer optional. It's essential for business compliance, for customer expectation, and also corporate responsibility. Sustainability has become a key pillar in how companies operate. So therefore, having accurate data about our environmental impact is critical for making informed decisions. But as many of us know, calculating emission hasn't always been straightforward. Every shipment is different. By mode, by region, by let's say the weight carrier, the distance, and all other attributes. What you can see here in this slide, in the left part, it's a list of greenhouse gases. Like we all know carbon dioxide, but we also have methane, we have nitrous oxide, also other fluorinated gases, and as well as black carbon. A hefty list of gases. But what's gathering all these gases is the CO2, the carbon dioxide equivalent. So how do we get to that carbon dioxide equivalent? Is by applying a global warming potential factor to each of these gases in order to have a unique measure on it. So OTM can apply a global warming potential factor to each of the gases and make the calculation in providing a carbon dioxide equivalent. In the right part of the slide, we can see an extract, from a standard from the Global Logistics Emission Council's framework. So it's exactly the emission factors, the example for emission factors in Europe. And within these basic emission factors, we can notice, let's say, a high gross vehicle, HGV called here, that emits 125 grams of CO2 equivalent per each ton kilometer. And we can notice also that we can go up to a van that emits 840 grams of CO2 equivalent per ton kilometer. So by having these factors that are provided again by the GLEC framework, and knowing the basic vehicle type that we are using, we can already start to calculate and report, let's say, report the emission, and that's what we call a start level for reporting. Again, knowing the equipment and these factors. So now let me go into the system, and I will switch you to OTM. One moment, and let me make it a bit bigger, and here. So, just to paint a bit the picture, yeah, here we created a demo data set and we are imagining a manufacturer based in Germany, yeah, that delivers around the world, yeah. Uh, so on the top header of this dashboard, we can see key metrics, yeah. So we are starting with the total amount of shipments. Now in this demo data set, we have over 10,000 of shipments. Then we have the total emissions, yeah, calculated in kilograms of carbon dioxide, yeah. So you can notice around over 17 million kilograms, yeah. You may have noticed the refresh, yeah. So this dashboard is it's built on the operational layer, yeah. So it's live, and okay, 70 million. What does that mean? Yeah, so we need to have kind of a measure. So we introduce here like an indicator that shows us how many trees should we plant in order to offset those emissions. And here it's quite a forest, I could say. Yeah. Okay. The next key metric is the total ton kilometer (TKM). Yeah, we'll see later that we have transported over all the shipments. And the last one, and it's one of the most important key indicators as mentioned by the GLEC framework, is the freight emission intensity. Yeah, that is measured in kilograms of CO2 per ton kilometer. Yeah, and why is this so important? It's exactly you need to here is the demo data set, but if you were to implement, this would be your freight emission intensity factor. Yeah, so this is built across all the entire shipment set and can be used to make benchmarks, compare the emissions on lines, etc. Yeah, and this is a key reporting indicator according to the GLEC framework. Yeah. On the bottom part, yeah, we see detailed insights, yeah, around the data set, yeah. On the left part, we notice the total emissions, yeah, per each transport mode, and we can notice directly that, let's say, our truckload transportation, yeah, makes the highest amount out of this data set, yeah. On the right part, we have a map layer that represents the total emissions per our destination countries, yeah, delivery countries. What is nice about this data visualization layer is that you can embed the, let's say, filters, and the data can automatically refresh, yeah, automatically filtered, and can provide me specific insights. Yeah, for example, I clicked on Germany and the data was filtered on France. I click, sorry. Okay, I click on Germany. We can notice how the insights are recalculated. Yeah, so Germany, yeah, we have truckload, we have rail transport, and counts for 518 trees. Yeah. Okay, if we go a bit below, we can introduce, we can have other examples or other details, yeah, around the emissions that we tracked. For example, left it's freight emission intensity per our sources, yeah, which departs. On the left, we have a freight emission intensity per each mode. Yeah, we can notice that. And also a good fact about the emission reporting is that we can really apply those factors and vehicle types, and we can calculate the emission for all modes. Yeah, so as long as they are in a standard, or you want to use your measure, you can apply it and calculate for each mode. Yeah, in this data set, we have modes like air, truckload, vessel, barge, rail, etc. Yeah. And using the data visualization capabilities and reporting, yeah, we can have all sorts of data represented, yeah. Like we have a spread by days, by months, yeah, and even we can have let's say a total emission per each service provider, yeah. So we can notice, for example, in this set that Maersk, we have many containers, yeah, here that we are transporting in the demo data set. It's accountable of more emissions, yeah. So now that we see how a report could look like, yeah, I want to dig a bit into a workbench, yeah, in order to see the details, yeah, on how those data for each shipment were calculated, yeah. On the left part, we have a list of 20 shipments, yeah, in this example. And as the first one is selected, yeah, on the top right part, we notice an emission activity record, yeah, that it's a child of the shipment table, yeah, that was created. And under this activity, emission activity record, uh, we copied, yeah, based on the rules, we copied all the information needed to do the compute of the carbon dioxide equivalent emissions. Yeah, meaning by we copied, let's say, the source location, the destination location, the mode, the type of equipment, and all other remarks that could help us and are used in the calculation. So if we are scrolling a bit down, we notice the remark area where we copied information like the vehicle type, yeah, generic vehicle type. There is a medium goods vehicle, yeah, and we can also copy different information, yeah. As we did so earlier with the trees offset, yeah, we introduce also a tree offset by each shipment, yeah. Okay, now that we saw all this information, let's go to the next step and see how we actually can set up OTM in order to calculate those emissions. I will switch a bit on the slide. And how do we do this? Yeah, the first part that we need to know is to define the shipment, the emission shipment scope. Yeah, which shipments do we want to track? Yeah. So we are starting by configuring which emissions gases are tracked. Yeah. Uh, for example, the GLEC framework, yeah, gives us all the values, all the emission factors in CO2 equivalent. Yeah. So that kind of helps us, yeah, not to track all the gases and their global warming potential. So the GLEC framework already computed that into their factors. Yeah. So once we are configuring which emission gases are tracked, we need to configure what elements, what emission data we need to copy into this shipment activity. Yeah. So for example, vehicle type, we saw it earlier, fuel, and other details that are used in the calculation. Yeah. And as is also specified here, so after we defining this emission shipment scope, the output is the creation of the emission activity record, yeah, as a child of the shipment. So for every relevant shipment, yeah, that it's included on the scope, OTM will create an emission activity, yeah. And now we are passing to the second step, when against this emission activity that was created in the first step, we need to define how the emissions are calculated, yeah? So I'm getting back, we need to define those emission factors, like the grid in the GLEC framework with the emission factors. And of course, after we have all the elements, yeah, copied, and also the emission factors, we need to apply an activity level formula expression, yeah, that actually gives OTM the formula to apply in order to compute the emissions, yeah. Okay, so now I'll go back into the system, yeah, and have a look on how we defined for this demo data set, yeah. So as told, the first thing we will define emission activity rules, yeah. I have a list of rules, different rules for mode, yeah. I will take the one that is truck load for Europe, yeah. Let me just enlarge the screen, yeah. So emission activity rule, we can set up different emission activity rules, yeah, to make it mode specific and region based, yeah. So we have here mode, region. As told, we need to define which gases are tracking, and that is made through the activity type, yeah. And within this activity type, we are defining which emissions, for example, here is named indirect emissions, we want to track scope 3, and then, as told, the GLEC framework helps us, it gives us the values in CO2 equivalent, so we already set it up in CO2 equivalent. And then underneath we have a list of attributes, yeah, that can be mode specific, that we want to copy from the shipment element, the keyment, or other elements linked with the shipment into the emission activity record, yeah, that will be created. So once I have this, yeah, another important key figure is the data configuration, yeah. So really this data configuration allows us full flexibility in which attributes we will use in our emissions calculation, yeah. So here it's a simple example, yeah. So we'll identify from the shipment equipment group, and it will be copied to the shipment to the emission activity created, the fuel and the vehicle type. These are two attributes for this truckload move, yeah. Okay, so once we are defining which shipments to track, in this case truckload within Europe, the second step will be to actually define the rule under which the calculation is made, yeah. And I'll go to the emission rule set. Here I have many emission rules, yeah, that are mode dependent, or maybe you can have different the same mode, yeah. You can potentially define an emission activity rule, yeah, that it's worldwide applied, but then through emission rules you can define different calculation methods for Europe, for South America, for North America, depending on the factors. I'll go again on the one that is called truckload Europe CO2 equivalent. And again, here we can control, let's say, again, the mode from which region to which region. As stated, yeah, we can define multiple zones, yeah. I think more better example would be ocean moves, yeah, because they are trade line dependent, yeah. So you would define different trade lines, yeah, which one with its own factor that will be applied, yeah. Then you can see directly on the screen on the bottom part is the emission factors grid, yeah. So actually we are defining, and here is an example taken from the GLEC framework exactly. So we saw on the first slide the first 4 rows, yeah. Even if we do not know the fuel, we have basic knowledge on our equipment, yeah. And we map those values that we saw earlier in the first slide, like for example for an high gross vehicle, yeah, it's 0.125 kilograms this time, so 125 grams per ton kilometer, yeah. We continue just as an example, yeah. We defined also the other factors, yeah, based on more detail, yeah, provided as in the framework, yeah. But again, just to get a step back, as a first level, if you know basic vehicle information, you have this factor in the GLEC framework, and you can start already calculate. And now we'll have a look on the engine, yeah, so that really calculates computes the maths, yeah, the CO2 equivalent. And you notice here that we have an activity level formula expression, yeah. This is the formula that it's applied at the shipment level, but we also have the possibility to control and define an activity detail level formula expression, yeah. And what's the difference? The first is at the shipment level. The second one takes into account each stop, yeah, with a running weight, applying also the distance component and the weight that it's carried on each stop, yeah. On this example, I will open the activity level formula expression, yeah. And what we can see here are a list of expression identifiers, yeah. So it's all the objects that we're defining, all the objects that it will be used in the calculation, yeah, in the emission activity. So we have the first is weight, yeah, weight is always important. We define as F the emission factor, so the emission factor that resides in the grid that you saw earlier. we have, let's say, and also the distance. Distance is also important in calculating emissions, yeah. And all are computed. You can see the formula below, yeah. It's fully configurable, yeah. So you can add your elements. You can define formulas. Here is the example from the Glake framework. So the total emissions, yeah, in kilograms of CO2 equivalent will be equal the weight divided by 1000 because the measurement is in tons, yeah, multiplied by the distance and the emission factor, yeah, that was matched against our shipment. Okay, and now that we have seen this, we can recap a bit, yeah. So if we are taking again an example, yeah, we have a source, a destination, it's our shipment, yeah. On the top bottom part is the shipment that we want to track, the emission activity record, yeah? And that is controlled through the region and transportation mode, as we saw, yeah? So we have this scope, yeah? On the bottom part, we see the elements that were copied into the emission activity record and were used to calculate the CO2 equivalent emissions, yeah? So we copied the weight over 4 tons, distance over 700 kilometers, yeah? So this comes from the shipment. And then we have the vehicle type that we identified based on the equipment group as an MGV, and the emission factor from the grid. Yeah, it was matched and copied to this shipment activity. Then OTM will compute and apply the formula that we saw earlier. Yeah, so the 4,362 kilos will divide by 1,000 to get the tons, multiplied by 731 the distance, multiplied by 0.21 kilograms per ton kilometer, and we end up with our total emission for this shipment, 670.33 kilograms of CO2 equivalent. So that is calculated based on the emission rule that we saw. And with this being said, yeah, OTM really allows you, at least at the first level, secondary free, to calculate the emission, no matter the mode, by following different standards or your own, yeah. We just saw an example from the Global Logistics Emissions Council, but you can apply other standards or other calculations. And with this, I'm saying thank you, and I'm open for questions. Yeah. So.